That's easy.
On the warm up.
Oh, wait, no, you got it. 36.
I found the area we can hire.
Oh my gosh, I know how to do it.
That's a good idea.
It's the same. So 180 minus 3.
Oh, really? If you say, you have to get.
Yeah.
That'd be a equation.
I mean, that's the language.
So it's what, 190. Wait, but it's 6. I got 4 pi.
Isn't it also?
Wait, why did?
Okay,
I got four.
take the.
Yeah, 4 pi. I didn't
Yes,
know
4 pi.
Oh, you mean for the area?
Yeah.
Oh, okay, no, I was thinking like, yeah, you're right. What?
Wait, the length of it
It's just pi.
Yeah. Wait, why is it just pi?
Because you end up with 12 pi times 40 over 3, which is equal to 1 over 3. No, not 1, 12. It's equal to something. So I'm saying 12.
Are we ready?
And like 30. How do you get 30?
And check with your neighbor when you're done with your sign, check again with your code sign, make sure everything's looking good.
No, it's yeah. Oh.
Wait, Mr. Lieber. Look at this graph.
Oh,
I did my.
What's
I got 100.
But okay, and then the length is 4 over 3 pi. Yeah.
4 pi over 3.
Okay, that's how it's, yes.
Oh, they were right. Right? 1.3 pi. Oh. The period is 3 pi. Divided by half. You come still play. Yeah. Wow, we're missing that whole over.
Well, Oliver's here, just move next to Augie.
Is Oliver?
Yeah. Well, since Una's not here.
Oh, Una's been out for a while.
We hope we're okay.
Actually, I'm not weird. I'm not. I'm gonna be in. Like,
Well,
Wait,
south.
is
The
it
question
the
also
arch-
needs to serve on
I
Sunday.
think we're doing that.
240?
We haven't.
Let's go down. I might just think, it's like, remember what it's.
Boulder was Boulder was having.
Wait, isn't it arc length?
Yeah, it is. You're not going right. Going right.
No, we did talk about it.
Leaving right now. The Carter's.
Well, because these ones are within.
That sounds so
It doesn't make
far.
sense. Am I right, Mr.?
Wait,
Yeah. Then he's going tomorrow morning.
40?
Oh, yeah, he's picking up my.
Are we finished? You ready to go?
I tried to.
Another 2 minutes.
Yeah.
Emma, you know
The
that?
R length.
Okay, so it sounds like we are finished. Okay, so for the f of x equals sine of x, is this a good way to start making just a grid like this? Is this? If I want, yeah, but is this setting us up for success? Is that?
Yeah, it goes both ways.
Yeah, that's true. Are we good?
No.
I prefer to see an emphasis on the,
First
quadrant.
I mean, first and
no,
fourth, the right
Yeah.
side.
the x axis. Would that make sense? An emphasis on x axis? Because of y, hey guys, because the y only goes from -1 to 1, right? So I don't need a big old y axis here. And generally I focus on the first and fourth quadrants, but we could go in both directions. It goes on forever. Now we know that this goes all the way up to 1, all the way down to -1. And when I say do a good job, that means I'm going to want you to mark the x-axis appropriately. And first thing I'm going to mark is, well, 0 is kind of already marked. By 2 pi. And we could, it doesn't matter what order you do this in. And then that 2 pi is divided into how many pieces?
5.
4 pieces.
You can divide it into as many as you like, but we're going to divide it into 4 because
Pi over 2.
of what?
Unit circle.
Unit circle is divided into 4 quadrants, right? So each one of these represents a quadrant. And of course, marking this middle one is pi. Before that is pi over 2, and this is 3 pi over 2. Do you have that on your graph? Did you have to do this for homework? I don't think so. How are you supposed to even know this?
Unit
We did it last class.
We talked about it. We didn't do a whole lot of it. And you all brought your pocket signs.
Yeah.
Pocket signs. You take your left hand. Okay, from point of view. Okay, so the first point I'm going to have from left to right is 0. Then
Pi over 2.
are we good with that? Pi over 2 comma 1. Then pi comma 0, 3 pi over 2 comma -1, 2 pi comma 0. All those values come from the unit circle, specifically the y coordinates of wherever we are on that graph, because it's sine, exactly. And then, oh, I can't go above that one. That would not be doing a good job. So maybe right there. I'm really trying to do a good job. Did I do okay?
Yeah.
Does it stop at 2 pi?
No.
No, it keeps going. The function is called periodic, right? So this is one period of a function. Goes forever at left and right, but this is enough. And I didn't specify how many periods. If I don't specify, then all I want is 1 period. Is fine. If I say 2 periods, then please give me 2 periods. You go all the way up to 4 pi or all the way back to all the way back. If I want 2 periods, that you would go all the way back to, you could go -2 pi if you have this already. Okay, so that is f of x equals sine of x. And for g of x equals cosine of x, I'm going to make the axes just the same. I'm going to focus on that y-axis, instead of the x-axis. And I know we have that 1 up here, so if I remember correctly, it kind of looks like this. Any questions?
No, it's.
Maybe your question is, why didn't you do it right, Mr. Lieberman?
Wait, if you think about it, it could be right.
It could be right, but if I'm talking about just f of x equals cosine of x, what I need to do is divide this into 2 pi, and just like the last one, 4 different parts,
0.
3 pi over 2, and we know that we're going to add to 0 comma 1 for this one. I'm going to bring that down just because that was a little bit extreme there. And we have -1 too, so I think these are the 5 points. And anytime you graph a sine or cosine, I'm going to want to see 5 key points. These points that are here. Does that make sense that we need 5? Yes, Jonas?
Do you care about having it line up with like pi over 6 as well? Those points as
No, these are the 5 I care about, and the other ones will just kind of fall in line. As long as you're not doing something crazy like this, right? That's gonna be a problem.
Yeah.
Or if you're doing a zigzag, I don't want that. I just want it to be a chill cosine graph where it. Sine and cosine are both family of functions. Remember? Could you check to see if your neighbor remembers that word? Sine and cosine are both
Sine is cosine is sine of x plus sine of x plus pi over
The family of functions is called sinusoidal. And there's a very specific relationship between the two of them. But they're both sinusoidal. Yes.
Oh, never mind. Sorry, I thought you were saying like how do they relate to each other?
Yeah, that'd be
Oh, yeah. Sorry, that's a different question. And you're correct. You definitely relate to one
I
another.
was gonna give them.
Maybe next time. Number 2. Now we've spoken about radians in this class. You know that radians are a way to measure
Degree. Angles.
angles, such as degrees are a way to measure angles. And I think you can convert from radians to degrees and degrees to radians, I hope. But what is 1 radian? What does it even mean? Simran, what do you think?
We said it's pi over 180.
So that's the meaning of it? Pi over 180?
No.
No?
Oh, it's like the circumference.
Is it pi over 180?
180 over pi.
180 over pi? That's what you said, 180 over pi or pi over 180? Okay.
There's something in terms of degrees.
So we could convert it to degrees. That's a different question. We could convert this. I don't know if this is a definition, but if we want to convert this, we use unit analysis. And what has to go on the bottom?
Pi.
Pi is on the bottom,
180.
radians have.
Radians have to go on the bottom. So normally we do pi radians is the same thing as 180 degrees. So yeah, we could say that 1 radian is equal to 180 pi degrees, but I'm not sure that's what it is. That's not what it means. Good question. Is it something to do with circumference?
Yes.
Kind of. Anyone know by definition? I didn't tell you what a radian is. I just said one way, all the way around is 2 pi radian. That's all I said. I didn't say what 1 radian is, though. Do you have another idea what it is? Half of a period. Why?
Is that right?
Yeah, well, why do you think that?
Because like when you would draw out the points of a unit circle, like half of it is gonna give you, wait. Actually, I don't.
Okay. So you're still in the process of developing this concept, and that's quite appropriate. So thank you for sharing with us. Does anyone else have an idea what a radian is? Yeah, Jonas?
Do with like arc length, something like that, like
It
maybe 1
does.
unit of arc length or something.
Yes, it has to do with arc length. Specifically, if you were to take a circle, let's say this circle down here, and see that radius is six inches. Area equals circumference. That's an interesting thought. I think you had two concepts kind of like clash. I know you know that's not true. But if we were to take some yarn and measure that 6-inch radius here and a bunch of those and try to half that, how many would you need to go halfway?
2 pi.
180 over 5. Nope.
No, 2 pi. 2 pi are higher.
No, seriously, think about it. You seriously have some yarn here, you try to like get some glue and like
2 pi.
actually.
36 pi.
Does it make sense that to go halfway, you would need 3.14 of those radiuses? Right? Isn't halfway
Yeah, halfway would just be pi.
pi radians?
Oh,
So what 1 radian is if you take a radius and just lay it along what you're saying, but Jonas is absolutely correct. If you make an arc length, then the length that it takes to go 1 radius is 1 radian. By definition of a radian. So to go all the way around, you need 2 pi radians, which is about 6.28 of those radiuses. One of the math teachers, I thought this was really smart. This is the first time I heard it this year. Like, why do we call them radians? Why not just call them radiuses? How many radiuses do we need to go all the way around? I thought, well, a little bit more than 6. We need 6.28 to go all the way around. That's no matter what size the circle is. So we've been dealing with in terms of pi, but I just want to let you know the definition of a radian is how far does it 1 radius wrap around the circle. Now, if we want to calculate the degrees, and I'm glad that you brought this up, that it relates to 180. We know that 180 divided by 3 is 60. So if we're dividing by a little bit more than 3, that means this would be a little bit, that the answer here would be a little bit less than 60. Does that make sense if we're dividing by more than 3? We're going to get like 50. I think it is 57-ish. You may want to tuck that in your back pocket. It's not necessary. What you do need to know is that pi over 3 radians is equal to 60 degrees. You definitely have to know that. Now, you know that the symbol for radians is nothing. So could I have just written this question as what is 1?
oh.
Well, I mean.
What is this? That's completely
It's a
different.
number.
It's a number, right? It has to be in context. So if we're talking about an angle and I put an angle here and I say 1 right there, well, that's also a little bit ambiguous, isn't it? That could be the name of an angle. So just in context, just make sure you're using your best judgment. But generally, if there's no pi involved, we'll put the radians there. So it's clear what we're talking about.
So you say in this, you say 6 inches is 1 radian for that circle?
Well, yes, the length of it is 6 inches, but 1 radian is the arc length that it goes. So it attaches to angles. That's why it's approximately 57 degrees. Okay, so the length, what does that even say right there? The length of arc AB. So I'd like to talk us through what they did to do this problem. Yeah, Connor.
Yeah.
I like it. Okay.
So
basically you start out by finding the circumference of the circle.
Okay.
Which is like the outside line.
Okay.
And then circumference equals 2 pi times r, or pi times diameter.
Okay.
And we know that 2 times 6 is 12. So it's 12 pi is
Okay.
the circumference. And then since 40 degrees is the center angle,
Mhm.
we know that that arc is 40 out of 160 or 360.
Okay, so 40 out of 360.
So if you multiply 40 over 360 times 12 pi, then you get 1,440 pi over 360,
Okay.
which equals,
Equals 4 pi.
yeah.
Well, instead of making,
Or
let's do some canceling here. Let's cancel those zeros, right?
I got a little bit confused with which problem I was on.
Okay.
So
It
it
happens.
actually equals 4 pi over.
Okay, well, yeah, just in terms of our work here, what should we cancel next?
4.
Maybe the 12 and the
12 does go into 36 nicely, doesn't it? 3 times. So I think that gives us 4 pi over 3. And the units here would be, I did add them a little bit later, 4 pi over 3.
Or radius.
I added them. I added some units.
Huh.
Are there inches?
so it's the length, which is
It's the length. It needs some sort of unit. So this is definitely inches. We can't call it radians. That would be an angle measure. Thank you very much. Who else already had that for pi over 3? A few people. Does it make sense how we got it? Got it. And we could generalize that by saying that arc length, and the letter we use for arc length, I don't know why, but it's S, lowercase s. This is arc length. S equals, and I'll say theta over 360. Does this make sense to say theta over 360?
Well, it depends if the theta is.
Let's talk about it. We'll talk about it. No, and this angle has to be the measure of this arc, measure the arc. Times 2 pi r. Does that resonate as true? And maybe something you did in geometry? Yes? Yeah, okay. I hope so. Okay, so for the area of the sector, are we comfortable with the vocabulary sector?
Yes.
It just means this guy right here. So to get that, we're going to start with, bless you. Not the circumference of the circle, but the area of the circle. And just like Connor did, in this case, we're going to say that it's 4 over 360 times pi times 36. Is that clear? Which is actually pretty nice, isn't it? This works out to be just 4 pi. And what are the units?
Inches square.
4 square inches. So it's a yeah, it's a measure of area, so it's square. Are we okay with this? I do want to show you the beauty of using radians with both of these formulas. Now let me put them both here. The area of the sector is also theta over 360 times pi r squared here. Now, if we're in radians, instead of 360 degrees, we're going to use 2 pi. So get this. Right, theta over 2 pi times 2 pi r.
It's just theta.
Yeah, if you're counting in radians, arc length is equal to theta times r. And this is something I want you to keep in mind. S represents the arc length.
Yeah.
So to get the arc length, if you know the angle measure in radians, just multiply that by the radius and you have the arc length. That's the thing about what's that? Because 360 is 2 pi, isn't it nice? It works out so prettily. If that's a word, I don't know. But it works out so nicely. And with our unit circle just being a radius of 1, anytime we talk about an angle on the unit circle, we're also talking about the arc length that goes to that angle. Yes, yeah.
But if our theta was 40 radian 6, 40 times 6.
Yeah, notice that we've gone from degrees to,
Oh, so we would have to translate 40.
yeah, we'd have to make sure we're in radians. So thank you for reminding us here that this has to be in radians because it's not going to work for degrees. And by the same token, the area of a sector, instead of saying theta over 360, we're going to say theta over 2 pi because that's radians. Does this work out nicely?
No,
Not quite as nice, but it's still nice. You
Cancel the
cancel,
pi.
cancel the pi. And generally what we say is that the area is equal to 1/2 r squared theta. This is what you're going to see in the future. And this would also be good for you to tuck into your tool belts. Just make sure that theta is measured in radians. Both of these, it's got to be in radians. Otherwise, if it's degrees, you can just start here. Theta out of 360. And that's fine too. Just make sure you're dealing with the right vocabulary for the concept that you're dealing with. Any questions? Perhaps your question is, can we try some more graphing, Mr. Lieberman? I knew it. The answer is yes, you may. Would you please graph the following function, f of x? Well, don't graph it yet. Let's talk about it. 2 sine of 3x plus 1.
Oh.
To write this down and discuss with your neighbor what happened to our fundamental periods.
Three, period.
Our period is divided by a calendar.
Yeah, it's divided.
And then the y values of
Double. And then.
And why is it both?
Hey, don't draw it just yet. Don't draw it just yet. Just
I
talk.
can't help myself.
Can you show me your pocket sign, please?
Wait, what is?
Show me your pocket sine wave, yes. Now show me what this 2 is going to do to that pocket sine wave. We're going to stretch it by factor 2, which changes the amplitude of that sine wave. Yes. Can you show me what that 3 does? Show me what that 3 does. Now, it squashes it, right? Compresses it horizontally by a factor of 1/3. Yeah, so it does this to this, doesn't it? And then that +1 moves it up 1. So let's graph this. I know it moved up, so I'm going to focus a little bit on the upper portion. And at 1, I'm going to draw a dashed line. Why am I going to do that? It's the midline. Does that make sense to put midline there? Yes.
It's just the plus whatever.
It always is. Yes, absolutely. This is also called the sinusoidal axis in other places. Instead of marking this as a 2 pi, I'm going to mark this as 2 pi over 3. How did you know? We divided everything by 3. Are we good with this? How many pieces parts am I going to divide that 2 pi over 3 into?
4 parts.
4. Why 4 parts? 4 quadrants. So before I divide into 4 parts, I'm going to take that 2 pi over 3 and cut it in half. What is half of 2 pi over 3?
2 pi over 6.
Pi over 3. Can you see that visually? Like from the unit circle, half of 2 pi over 3 is pi over 3. Or just half of 2 pi over 3, pi over 3. Half of pi over 3. Can you see that visually in the circle? And of course, half of 2 pi over 3, pi over 3. I said pi over 6, excuse me. And then to get that last one, I'm just going to count 1 pi over 6, 2 pi over 6, 3 pi over 6, which is 1 pi over 2. And how many points do I want? I want 5 points. Let's see if you could already plot them. You and your neighbor may want to talk about it.
Wait, what's on
Okay, please, here.
this?
No, it's 1 number.
I've done it. I've done it well.
Well, what
is that?
Yeah, no, but, you know, and then
The
here, so it's plus
I'm gonna go to 1, 2. No, couldn't
This is mine, mine.
That still goes up one and multiply by two. The first one started by two.
Initially, but I've done it again.
Are you Britney Spears perhaps?
I've done it again. But it was. Oh, you right.
Later. What?
First point, you put it right there,
0,1.
0,1.
What he called me dumb.
There's our first point. Our second point is pi over 6 comma. Is that clear? Yeah, pi over 6 comma 3. Too much chit chat, too much laughing. Let's reel it in.
Locked in the whole time.
I see that. I appreciate it, Augie. Next point,
Probably in the middle right there.
specifically pi over 3 comma 1. Next point, pi over 2 comma -1. All right, we're just going 2 up and 2 down from that midline.
Use because we did the one up one first, so I can't.
I see, yeah. Yeah, actually, I went up last, but I drew it first, right? I squashed it and did this. And then what was in my head is all moving up. And now we just do a good job.
Wait,
Yeah, how do we know what the amplitude?
What's wrong?
Well,
What's wrong? Did I do something wrong? I did a terrible idea. I did a terrible job, excuse me.
oh,
Something like that.
to be straight at the start.
oh yeah, it has to be
Yeah.
like, it has to look linear.
Yeah.
Oh,
Well, it is linear.
Wait, how do you know?
because
Wait,
most
is it-
of initially.
It's almost linear. Almost like a slope of 1, but I'm not actually gonna try to get the right slope. I'm just trying to get the general behavior. Is this clear?
Oh, so
Yes, Simran?
Wait, for the amplitude, initially, like in a regular sine graph, it would have been at one, right? But then
Exactly.
you multiply it by two. So
Yeah.
2 and then up, oh, so it's 3.
Exactly. You're figuring things out. I love it. Any other questions? I like when our own questions are answered. Let's do some of the packet, shall we? Perhaps that was your question. We are going to go to, where are we? Does this make sense? Midline is a vertical translation.
Yeah.
Amplitude is vertical dilation. What do you think, Oliver? Makes sense? The period is just a horizontal dilation. Oh, I'm sorry. I got to go back to warm for just a moment. I'm so sorry to interrupt the flow here. But let's talk about another thing that we didn't talk about. After period, let's talk about frequency. Would you check to see what the frequency is for this with your neighbor?
No, it's
three over too high.
Okay. So I want to give this some meaning now. I want to give this some meaning. Imagine if we continued this graph all the way to 2 pi. Imagine, because right now it's at 2 pi over 3. Imagine we graphed all the way to 2 pi. Do you see what would happen? There would be 3
3 of them.
periods.
3 of them.
3 periods.
So the frequency is 3 sine waves per 2 pi. Per 2 pi.
A sine wave is the whole thing.
The sine wave is, yeah, a single thing that we're comfortable with at this point. So that's what that means. So for a normal sine whose period hasn't been changed, the period is 2 pi, which means the frequency is
3 over 2 pi.
1 over 2 pi. Does that register? There's 1 period for 2 pi. Yes.
So for 3 sine waves, that would make. Wait, 3 of those graphs would make 2 pi.
Perfect. Yes. And this is what it's saying. There's 3 other sine waves in 2 pi. So give us some meaning. Yeah, Haley.
So only a horizontal dilation affects the frequency.
That was so pretty. Yeah, that's perfect. Yeah. Horizontal dilation affects the frequency. Otherwise, the frequency is just 1 over 2 pi. Now, let's go to the packet as promised. Whatever you need to do. Okay, so with this equation up here, does this make sense? Like if B is over here, then we have a horizontal dilation by a factor of 1/b.
Yeah.
And it's absolute value because that negative would just go to flipping over that's the y-axis. So we just care about how big is it compressed or stretched or compressed. So with that in mind, the period is, I would think about this as 1/b times 2 pi of absolute value. Right, the period is equal to, I normally just say 2 pi over b, and I strip away the negative behavior because that again is a reflection.
Wait, do you always multiply it by 2 pi?
Yeah, because that's the fundamental period. And we take our period like we did here and then multiply it by 1/3 because we had that 3.
And D is the dilation factor.
But B is the dilation factor. That was nicely said. B is right there, the factor of the theta.
But can't the period sometimes like not have pi in it? Like what
Yeah.
if the period's like?
Yeah, you'll see. I'll get there. Don't worry. You are correct. From here, let's see. We have P equals 2 pi over B. Can you make a quick expression for B, please? Just algebraically. And check with your neighbor. Just B equals.
Yeah. What it,
On the count of 3, let's hear it. So B is equal to 1, 2, 3.
2 pi over p.
2 pi over P. And remember, there's that trick. Just if you have two fractions that equal each other, you could take the diagonals and switch.
but that's that.
Yeah, you could do that if you like. Just if you want to account for positive and negative, just trying to get the basic ideas here. Let's go to example 3. Go ahead and analyze. Example 3.
Don't tell me.
Yeah, don't call it out. Don't call it out. Just discuss quietly with your neighbors if you like. We'll do one at a time. We are going to do 4. Okay. Show me A, B, C, or a D. What do you think it is? A, B, C, or a D? A, B, C. Take a look around, see what people are holding up. I'm saying everything but D. I believe this is A. This is A. Yeah, with your fingernails there. A, B, C, D. Yeah, check with people around you. We need a single answer.
Maybe I'm alive.
I think that's an A minus.
What?
Because I saw the
Oh, I chopped my arm.
exactly. Sacrifice.
Or
So
another arm. Or she has 2 arms.
Oh.
She has this and then it's like about the same one.
I think it's.
so many possibilities. I'm gonna ask one person to answer in just a second, so make sure you have something to say. That's okay. Okay, let's talk about 2-armed Haley. Example 3. Which one do you think it is?
I think it's F,
Why do you think it's A?
because you can tell the period is pi. And then
How do you tell that?
Con and I were looking at it from starting at the y-axis, and you can see like the patterns like repeated twice.
Okay, are you kind of maybe looking at this? You see that that's one period there?
So starting from
Oh, that's starting from the midline. Thank you for starting on the midline. Okay, good.
for the amplitude, if you start from that same midline, you can see that it goes up too and goes down too as well.
Okay, so it's definitely either this or this. And then, oh, so then I guess we're done. Are we good? And with that period being pi, that means the frequency is 1/pi. Do you see that? 1/pi just means that in that pi region, there is one sign, one period, 1/pi. Example 4, it's getting stronger. I'll give you a minute. Quietly discuss with your neighbor when you're ready. Discuss quietly. You'll be voting shortly.
I'll put you on, it's like. He's always like this.
For the implants.
10 more seconds. Okay. Okay, folks. The time for discussion is over for momentarily. Thank you. Show me your answer. A, B, C, or D. What is it? I'm saying I. That's interesting.
How did you do?
This is D. This is D. This is I. There's no I here. Let's imagine D is this one.
The answer-
Okay, so I'm saying mostly D's. Let's see. Mia, do you agree that the answer is D? Oh, so you think it's C? Why is it C? Okay.
Page,
Mm-hmm.
it says that, like, when, like, B is equal to, like, the frequency, and the period is 2/pi, or pi over B.
So you started with this, or did you look at the what information here?
The points that I received, well, it takes pi over 2 to get to the minimum maximum, so it would take another pi over 2 to get back.
Nice. So you're saying here is half of it, right? So another pi over 2 to get back, half, which means what? Okay, period is equal to pi.
Or 2 pi over B.
If the period is pi, then very simply the frequency is just the reciprocal of that, always. So I'm not sure it's necessary right now, but I want to hear about some other things you talked about.
Talked about how in between the maximum and the minimum, there's 10 points. And the midline would be 5 points away from that. Like 5 points below the maximum or 5 units above the minimum, which is y is equal to 1.
Okay, so that leaves off A and B, doesn't it?
C and D. Yeah.
Okay.
And then, I chose C, or I chose C because
Well, let's see. I'm not sure. I know that is a B right there. Right, this is B times X, isn't it? Exactly. So how do you figure out B? Is there a way to figure out B?
Yeah, we just did it.
Did we? Is there a way up here to figure out B?
P equals pi.
2 pi over P. So if that's 2 pi over, and our period here is pi, that means b is equal to 2, which means our answer is D.
Oh my God.
Wait, how did you get the period?
Are we good? Mia, thank you for your guidance there. Simran?
Wait, do you get the period because you add the x values to the maximum minimum and then divide by 2?
No. Because we know like.
Not necessarily.
It says because it's like maximum and minimum, so we know the next one's a maximum, so we know that it's like.
Oh, you won't spend
It's
pi
half
by 2
way,
times.
it's maximum.
Okay.
Yeah, from here to here is half, right? That's pi over 2. Any other questions? Perhaps your question is, can we try another? Yes, yes, you can. Hey, look at this number 5. This is great.
This is, oh my God. This is pretty successful.
What's that?
I said this is pretty successful.
I heard you say that's pretty amazing. Is that what it was?
I do think it's amazing.
Like negative, yeah, and to find. You know, pi. Or it's pi over the.
Okay.
Yeah, it's. But you have to. Oh, no.
Yeah.
Oh.
Oh, like, you know,
Oh,
the letter.
oh, this is
Oh,
the
no.
devil.
Oh.
Okay.
Wait, what's
D.
oh,
This is pi.
oh, this is,
Oh, no, that's not the,
you're right.
Do you want to check quietly with the people in front of you or behind you?
Oh my goodness. I got C.
Oh shit, yeah, it's
Wait.
pretty obvious.
Well, got C.
It's not.
So the period is 2 pi over B. The period here. Look at it, look at it, period here and pi over 2. Period of that.
No.
Pi.
Period equals 2 pi over you have to.
Got it. You got it?
yeah.
Oh.
Yeah, that's actually right, yeah, that's actually true. No.
Why'd you throw me off all the way?
Yeah.
See, actually, yeah. You don't have to follow me, why'd you throw me off?
5 seconds.
Gets really, this is no, gets better.
Oh, you. Good for you.
Okay. Is it A, B, C, or D? I'm seeing lots of C's. Did you all, first of all, did you disqualify A immediately?
Yeah.
Oh.
Just double check.
Why did we disqualify A?
Divide.
Mine is, yeah, we need a -1. A is definitely is a +1 there. Okay, so I saw a bunch of C's. Lee, do you agree that the answer is C?
Yeah, I got it.
Could you explain how you matched that
Well, because we had our divide at 1.
at 1?
Right.
Okay, so that fits.
And then we had our amplitude, and
It's kind of over there. Oh, it's almost over, isn't it? And then one other thing. And it's pi because, yeah, 2 pi divided by 2 is equal to pi. So everything lines up such that we are dealing with C. And I think we're okay with that. Ready to move on? Okay, so silly today. Okay, so this is something new. I think that so far maybe who's already seen all this stuff for last year? This next one may be a little bit of a change. We're doing phase shift. So phase shift is just another way of saying horizontal shift or translation.
Oh, so we're
So-
adding on.
Yeah, so depending on, and we did that yesterday or last time. X plus C is the phase shift of the graph. Sine of X by C by -C units. So it depends on what it is, opposite of what you would imagine. Yes,
does the B also matter in the phase shift?
yes, it does. Exactly. Definitely. We're gonna put those together soon, but let's see what you could do, for example, 6 already.
You guys, I'm just playing. So it's. This turns all these points. These turns all. You think this one, you're still very much. No.
No, here's.
No, it can't be cosine. It can be cosine or sine. How you look at it.
Oh, I see.
So it's here, you're not. Now, it can't be the same. Would you guys?
Well, all I know is being one and that the midline is at negative
Yeah,
one.
B.
Alright, so every single.
So because cosine you have.
And
Positive cosine looks like
I
that.
also
Negative cosine
know
looks like this.
that the amplitude is 3, so it definitely can't be B or D, so it's either A or C.
Amplitude don't.
And then X plus pi over 2.
Wait, no, it definitely is B.
It's B.
It's negative.
Wait, I thought you can't have a negative amplitude.
That's not the amplitude, that's the transformation rate.
Yeah, but that would you don't find.
Isn't it A or C? Wait, bro, am I wrong? Oh, shoot, I you just realized you're wrong.
Over two, then you get, oh, it is C, you must.
Oh, this is the same thing.
It can't be either. That's your stuff.
People like, no, that's not what I'm doing.
Yeah, I started.
I was right.
Wait, wait, am I right that it can't be here?
No, wait, I said
The negative?
Yeah, no, that's right. See, look, all of it.
Oh, yeah, you wanna translate basket, but this would be nice.
Yeah.
Literally it's opposite.
So if you move that.
Either way, but it's just gonna put it.
If that's a cosine graph.
If I start from 2 pi, if I find the cosine plus 2 pi, it's like negative 3 cosine.
We're learning.
So whatever this gets.
Are we ready?
No.
That's where you're saying the graph starts.
Augie's ready. Before we do this, can we take a moment to just appreciate how well constructed this question is?
I hate
Do you
it.
agree that this is a pretty good question? Like each
You
one is
understand
like
that?
kind of close.
Fire.
Maybe it's fire.
Do you like it?
Maybe. I like it. Before we actually answer also, let's just take a minute to talk about each one. Like without them, they all have a -1. Can you just show me 3 cosine X?
It's just like.
Just show me 3 cosine X. What I'm looking for is a shotgun. And then you imagine that it's going up 3 and down 3, of course. And can you please show me -3 cosine X?
This.
And now tack on that negative pi.
Wait.
It's X minus pi, which means it's gonna move over pi, yes? And here, so 3 sine X before any sort of shift, 3 sine of X, show me that one.
Like.
3 sine of X. And then plus pi over 2, moves it this way. And here, that -3 sine of X, take our sign this way, and then the -3 pi over 2 means we're going
Right.
to the right. 3 pi over 2. Okay, so which one is it? A, B, C, or D? A, B, C, or D? I see a little controversy. I see a little controversy. Let's see. Una is not here. Una, if you were here, we'd find you. Do you have a question?
No, I was just thinking.
You're hoping Destiny will call on you? Let's see. Get close, Kayla. What, can you tell us what you did? What's your answer? Do you think it's what?
I explained it to her.
Okay. What? So, quiet, please. I want to hear only Kayla now. Hey, you too. You too. Connor, Haley, please. I want to hear only Kayla right now. So it could be either cosine or sine. It's definitely sinusoidal. But you landed on D. So are you choosing sine or? I'd really like to hear only Kayla. She doesn't have a loud voice.
Well, I'm choosing.
Okay,
Yeah.
that's fine.
Well, I know the amplitude is 3, and so then point is that.
Okay. So we could see the midpoint here. at that -1, and you're choosing sine starting at what x value? 3 pi/2. Let me see if I can actually get my pins here. So 3 pi/2. So you're choosing this one. Okay.
If it starts with that, I thought it would be, a negative, since positive would be like, sort of the other way.
Okay. So I'm trying to get my, there they are. Okay, so you're going this way, right? So that it does look like a sine wave that's flipped upside down, doesn't it? Okay. I think that's it, isn't it? Are we done? It seems to be D.
I got C.
Interesting. But there seems to be controversy. Kayla, thank you very much. Yeah, Jonas, you have something.
Like my C, is it correct?
Sure.
So if you look at C, it says x plus pi/2, and that would mean you have to move to the like -pi/2. You assume that the graph would start there, and for that to be true, it would have to be -3 sine x plus pi/2.
Oh my.
Wait.
And it would work if it was -pi.
Yeah.
This would be correct. That would be
It
correct.
would also work if it was -3.
Yeah, it would work if it's negative. Yeah, right. All of these have like one. Kayla,
Don't worry,
thank you.
it's so confusing.
Yeah, me.
I was-
Quiet, please.
Like, how do you know when to start appearing on like the graph? Because I started.
I'm sorry.
visualizing
I'm
my
trying to
graph.
listen to me only.
I started visualizing my graph of sine
Okay.
at x is equal to pi/2.
Okay.
So I would never really catch on that it's negative because it's a periodic graph and I started at the midline. I like, how do you know? You have to start at 3 pi/2. Otherwise, you wouldn't know that it's going down.
This is a great question. And I'm gonna answer that by first of all, asking you a question. Is this a sine graph or a cosine graph?
Yeah.
It's both.
It could be.
It's either one. It depends on how you see it. Yeah, you're not wrong. I would agree with you. Actually, it would make a lot of sense to start here as a sine, like a sine wave with no negativity involved. But then we would need an x minus. And that's just not here. So we have to find which one is here.
All right.
Wait, well, look, you're not wrong. It's like, well, the one that should have been there wasn't there, so you have to see the other ones. And there is some elimination, like here, if we try to see it as a cosine, Connor's right. This would be correct if this said
Negative.
-3, right? We take that cosine. That'd be actually maybe the easiest one there. It's just no shift, no phase shift. That'd be nice, but it's not one of the choices, so we need flexibility just in how we're looking at it. Yes, Oliver?
What's it called a phase shift? Like it didn't really, like, it kind of doesn't change, right?
It doesn't change. It's still the same wave, but how do we label it as a function? That's where we see a shift. Like if we see it as a -3 sine wave, then it's moving 3 pi/2 to the right.
Yeah.
I'm with you though. I would definitely see this as a sine wave starting here. That's how I see that. The sine is a good starting place. Simran.
Not -pi/2, then you immediately cancel that out. And then you go, did you check the sense to see the top possible?
Yeah,
Oh.
yeah.
And
This is
it's
just like,
possible.
there's process of elimination here. Oh, look at this one. Connor, you are like a soothsayer.
What?
A soothsayer. You're telling the future here. There's a B here, there's a phase shift, there's a little bit of everything.
All right, let's now work with the plus.
Oh,
Yeah,
They're all.
Right.
Wait, what if we make that easier?
Perfect.
They've already saved that.
You're standing talking.
Oh, okay.
Wait, so
And
they've
I
already saved.
I already did this, not looking for it. Yeah, I have to stay on how much. I don't know.
That works. So. How do we channel? So.
It's fun just to say it again.
Yeah, I'm saying.
Very
fun.
4.
Amplitude is 2.
Then you would be inclined to say that it's. Yeah. It's either there's.
I remember like.
Fire, so that would be like that would be pi over two.
No, it'd be tons of fun. Wait, you know what I'm saying? It's like, I haven't got there. On my own.
So like if it's runs, and pi over
It
two,
depends on how much.
and whatever that's I got pi over first pi over.
Yeah, one is in the.
No, I just literally want to-
It's not all trying to visualize and like from five to. One C.
It could be both, if it was.
How do you?
Like balance.
Yeah, I know it's either, end, but I don't know. It can't be, since it can't see it both ways, it could be one.
Seven not B.
Like, I don't know.
What's gonna be a sign graph? It's gonna be C.
Oh, yeah, no.
It's gonna be.
Basically, it's that determining what their cosine or some of the children have been. We wanted them, but not two. How can it be?
No, it's A. Start up. Yeah.
So start giving goes way back. If you look at it, it's like back corner here, and then that's fine. And then it's like, look, so the plan function start on the midline, but the midline is one.
Well, you could.
Yeah, look, this is you move it a quarter of pi.
But I don't know.
So it means that if we move it back. Look, we move it back that way. Oh, yeah, you're right. Actually,
It's not bad.
You're moving it to the right.
This is like something.
I was listening, and I was like, oh my God.
Uh-oh. Gross.
Yeah, I don't think you do either.
It's like
A
Remember
for,
Mr. Sim would make.
A for
also, if you did distribute the two.
Yeah, I don't think it's, you have to.
Like chicken breast.
B.
Yeah.
I got it.
I think.
I'm with the chicken. Wait, would you say Chick-fil-A is like half in top five?
Yeah.
City, like,
Yeah.
I think definitely like, for me, it's top three. I think, yeah, I could throw it down there too. It's like a guilty pleasure, but I do go to McDonald's a lot, like stuff like that too, but it's like, it's so packed, so that, I live right by it, you know, it's like this, yeah. That is, yeah, and so.
Okay, folks,
I just checked.
it's voting time. What'd you get?
I don't see.
A, B, C, or D. Interesting. Okay, we'll take a look around. There's a plethora of answers. Maybe there is more than one answer. Now, I want to hear from this only one person. Put your hands up. I hear only from Leah. So can you help us out? Which one do you think it is, Leah?
So I didn't really get an answer, but
After all of that, interesting. But I'm sure you had. But so where are you leaning?
I'm hearing a lot of A's, so maybe.
So you're just like playing the prices right and like whatever people say is what you're thinking. Is that kind of what you're doing?
Yeah.
Actually, that's what I'm looking for.
I'm debating between like if you distribute out the two or if,
Oh,
because I feel like that would change the answer. So
yeah. Well, in the form that it is right now, we see the phase shift.
you just leave it
We
like.
see it. Yeah, we just leave it like that. Yes.
Might be C.
Actually,
Again, I want to hear the voice of one person, only Leah. Yeah. So with that in mind,
Don't distribute it, then I think it's.
okay. So let's see. So if it's C, there's two on the outside. This is a match. They all have a two, and that represents the of the sign cosine. That represents the amplitude. It's amplitude, which is the vertical dilation. But yeah, amplitude specifically, and they all have a two there. This two has to do with the period. We compress this by a factor of 1/2, and that's why the period is. It should be pi, and that's all the same for all of them.
yeah.
Okay, so Leah, what is it exactly that led you to C?
Um. Wait, now that I'm trying it again, I feel like it might be A.
Okay, why A?
Definitely don't.
Wait, I'm feeling it.
Let's see, I switched on eight.
Wait, yeah, I'm not sure.
Well, let's see. Let's stick with this one and just see what's going on here. If you went to pi over 4, isn't that where the period starts?
Yes.
And it ends when I get to right here. And it does look like that's a sine wave. Does everything line up here for C?
Yep.
Okay, yeah, it looks like C is correct. Was there another one that's correct?
Okay. Perfect. I wouldn't say so. No, I think it's C. Can't be A.
Wait,
Because
why
A would be
even
2x minus.
If it was pi over 2.
Let's see. Can you make A correct just by changing this number here, please?
Pi over 2.
I was thinking.
It's silly, right? Wait, why would it be C? Because it could be this sine wave, but then if you move it right, pi over 4. Wait, if you move the original right pi over 4, that's what you're doing?
Yeah, exactly.
Like that. I have one. What's the significance of the 2 in the, like, outside of the parentheses?
Right there. That's the horizontal compression. It deals with the period. Yes, Simran? Yeah, exactly. Oh, it looks like this green one that I drew.
Like the graph.
Well, again, let's do A. If we want to make 8 correct, what would we have to replace that with? Does it make sense that if we replace that with pi over 2, we suddenly have a correct cosine graph? We have the cosine just move pi over 2. And doing that in red, so pi over 2, that would start up here and go here, right? That'd be correct. Moved over pi over 2, but it depends on how you see it. How you see it. And lastly, example A.
Practicing that. Oh. That was my idea.
Genius.
Wait. Yeah. Oh, we have to write.
Oh, midnight.
And actually, like 2 equations, one in terms of sine, one in terms of cosine. No.
It's actually. We see.
Here.
Why was it saying you come last?
Oh, they're ready? No.
We're doing
What's it?
So now figure out.
Wait, are you? It's fine.
Oh, doesn't, oh, I think it's nice.
Thank you.
Yeah.
I saw some mid house. Yeah, okay. Here, you have this class.
Yeah, just look, you have this point here.
And what?
And what this is. Sign of function. You want to go back normal line. This means it on the left one. Oh, yeah. So that's this one. Okay. Now we have 5.
Wait,
Yeah. So, okay.
Right.
Remember, I want one sine and one cosine, please.
oh my God.
No, but it's still one thing. So-
It's your P equals A sine pi.
No, it's fine.
Negative five sine.
I got it.
Plus 11. No, not plus 11.
It's plus 11.
You're moving up. The lowest time is like.
I got it. No, the
Got
midline.
it. I know you got it.
Oh, we have to go to the midline.
You're right.
Wait, what's your?
No, but we.
Yeah, we did.
About 20 seconds.
Oh, wait, never mind, never mind, never mind. No, next slide is.
Like you're what is the midline? When did it ever drop in the
Hey, 5 seconds. Okay, here we go. Show me A. Just kidding. Connor, can you tell us one of these? A, B, C, or D?
A, B, C, or, oh, for A is 5.
And can you tell us how you got that?
We can see that it goes, Y values go from 16 to 6. And if you subtract 6 from 16, you get 10. And we know that it's usually 1. And 10 divided by 2 is 5. 5 divided by 1 is 5.
Okay, are we good with that? I think that just half the 10. I think once you're at that, we're good with the 5 right here. Okay, so we got a 5. And it's the same for both of them, whether it's sine or cosine. The amplitude's going to be 5. Did you already have that 5? Now, someone in my last class said all you have to do is look at that 5, and that's where you get this from. Is that a pretty good idea? That seems like a disconnect from the concept completely. So please don't just like find random connections. Yeah, Simran. Is the amplitude always the A?
The absolute value.
Absolute value of the A. Yeah, you can have a negative. Amplitude will never be negative. But A could be negative. Okay, Connor, thank you for that. Okay, Chloe, can you tell us one other thing here? Either B, C, or D. What's that? How did you get plus 11? Are we good with that? Is this the midline? Okay, so this is plus 11 for both of those. It's a plus 11. Okay. Who'd like to give us the rest and how they got it? Yes, I'll give.
For the sine one, well, also for the cosine one, the period's pi over 6. And
Wait, how do you know that?
so,
Wait, period is pi over 6?
yeah, wait, no, the B is pi over 6.
How do you know
The period
that?
Yeah, the period is 12. but
Okay.
P is pi over 6.
How did you get that?
Because the relationship that we did earlier about P and the, about B and the period, I'm doing it right now. Like, I literally have it right here, but, because we know it's 12 because, from the two peaks, that it's from like 2 to 14.
Oh,
And then
nice. So from here to here.
so that's 12.
Nice.
And then you know that B is equal to 2 pi over the period, which is 12, pi over 12, so pi over 6.
Okay, pi over 6. Cool.
And then it's the same for both of them because it's the same amount of repeat.
Okay.
And then for
But
sine,
before it continues, are we good with that? Okay, keep on going.
and for sine, I got +1, so T +1,
Oh, interesting. How?
because what I thought about was that if you had like this value, like the one that would be in line with
Right there.
B, yeah,
Okay.
would be -1. I guess it'd be at -1 comma 11.
Why is it -1? How do you know that?
Because it's been like they've been working by 12, yeah. So a quarter jump would be 3.
Okay. Oh, so from here
Yeah.
back 3. Okay.
And then from there, since you know that sine functions start on the midline, then we know that this is the start of the sine function, just shifted over to the left by 1, which means to shift it over, like to undo that, you would put +1. Or like not to undo that, but to like represent that, you would put +1.
Are we good with that? Sermon, and then if you have another question, yes.
I think all you said is feeling that like change that makes it like sinusoidal
Uh-huh.
is like the plus C, like whether or not you need to left it. Right?
The thing that makes it sinusoidal is sine and or cosine.
Like whatever.
That's cute.
Like whenever you're like adding.
Don't close up yet, guys.
Whenever you're adding or subtracting to like the C, that's what makes it.
That's a midline. I'm sorry, that's the phase shift, yes. So what's
it. I mean.
the phase shift? That's not what makes it sinusoidal, though. Don't pack up yet, folks. Was there another question about this?
Yeah, we'll go
For cosine?
Oh, and that's for that one, the C is -2.
That was a minus.
2 point. Yeah, that was.
Yep. And last thing, guys, I hope you can see the from here. Do you see how you could get the coordinates of that unnamed point from 11,
Yeah.
just subtract 12 from there to get that -1. So you don't have to worry about dividing it into pieces.
Oh,
Great job today, folks. Your assignment is on Pearson. It's Pearson this time.
Thank you so much.
My pleasure. Great job.